Okay, so this, I split things up into two different chunks. We could have higher order derivatives first. A higher order derivative is very simply just taking derivatives of stuff that's a derivative to get more derivatives. So second order, or well, the second derivative of this function, we're given f to just be x sine x. And it's a real, okay, well, first things first, when we take this first derivative, we want to recognize that we have a product rule. So the f prime, this first derivative, is going to be a product rule from x and sine. And so the product rule, we take the left and we multiply it by the derivative of the right. So left d right, and then we go the other way around. We add the right function times the derivative of the left. Right? So we would have the left times the derivative of the right, and derivative of sine is just cosine. So left d right plus, we're going to do the right d left. So right is just sine, and d left, well, the derivative of x with respect to x is just 1. So we're multiplying this by 1, so we don't really need to write that down. So this is the first derivative. Now we're going to take the second derivative, and so all we do is we take f prime prime, which is going to be the derivative of f prime. So notice again, we're going to want to make sure we observe this product rule, make sure we do that correctly. So the left is just x still. So left d right. Now derivative of cosine, be careful with the signs because derivative of cosine is minus sine. So that's good. That's left d right plus now right d left. So plus the right, which is cosine. And then derivative, like we already talked about earlier, the derivative of just x with respect to x is 1. So we're really multiplying by 1 here, cosine times 1. And then that's that. So notice that this right here, just to kind of be clear, what's in the brackets is the derivative of just this first part right here, this product rule. Okay, and so now we just simply add on the derivative of sine, which is cosine. So obviously we can simplify this to kind of get the final answer. We're gonna have, let's see, the cosine plus cosine is 2 cosine x. And then we subtract because remember that we have that negative, right, the negative 1 in front of the sign, negative sign. So now minus x sine x. And so this is a valid solution you could represent for the second derivative of this function. So the main thing when you take these, when you take a second derivative of a function, it's really just the same scale as taking the derivative of any function. As long as you remember your derivative rules, you understand, and just make sure you apply those correctly, you'll be fine. So, and a lot of times the most difficult part can be just simplifying stuff. So if this was a more involved function with more, sketchy rules involved, lots of algebra, it can get a little bit more difficult. But the calculus is still the same. It's pretty straightforward. So now we have a little bit of a different problem. Find the given higher order derivative. And so what they're giving you is they're giving you the third derivative, but they're just asking for the fourth derivative. So what you can really think of, they're really just giving you some function. So to make it easier notationally to comprehend, they're really just giving you some function. I'm going to call it g because it's a different letter than f. Really just giving you a function g and calling it this, like this fourth root of x cubed. And they're really just asking for what? The derivative of that. So we're really just going to find g prime of x, right? So this is one way you could kind of reframe the question in your mind. Obviously, you don't have to do this. There's nothing special about this method. It's just one way to conceptually demonstrate that the third derivative of f is basically just a function. And if you take the derivative of it, there's no special additional rule. There's nothing else you have to worry about. It truly is just as straightforward as that. If you take the derivative, the next order, whatever you had, just take the derivative with the rules that you already know from just taking one derivative. So this, I think the greatest challenge here actually is just not getting intimidated by this absolutely disgusting notation offered in the problem. So a lot of times we forget that radicals are just fractional exponents. And in calculus, and if you've been doing your power rule long enough, you'll realize exponents are kind of nice. They're really sweet. They come out nice. They're easy to work with. They're very well behaved. So we can, let's re-represent this, right? So a fourth root is really just some number raised to the 1/4, a fraction exponent. So we're really, when we say x cubed to the fourth root, we're really saying x cubed raised to the power of just 1/4, right? And obviously, we can combine those exponents. We multiply these two numbers together. And this is an algebraic rule. This is not calculus, just to clarify, this is algebra. So then you'd have x to the 3/4 power. So this is much prettier to work with, and it's very obvious how to use the power rule to take this derivative, right? So g prime is, we just use the power rule. You take whatever's in the exponent, you throw it down in front as a constant, so 3/4 x, and then you subtract 1 from whatever the exponent was. So 3/4, if you take away 1, the same thing as taking away like 4/4, so you have negative 1/4. And so technically this is the answer. Like, so if you wrote this and put a circle around it, unless your teacher explicitly wanted you to simplify it in a very specific way, this is a completely valid answer. Other ways, I encourage you to get comfortable with being flexible with, seeing these exponents represented in different ways. For example, since it's a negative exponent in the numerator, let's throw it in the denominator to make it a positive exponent. So 3/4x to the 1/4. And if you were taking an MCQ exam, so if this is a multiple choice question, say on a multiple choice test, and neither of these representations were involved, what if the only possible answers they're giving you are in radical form? Well, remember, you can always convert this back to a radical. You can always go back and say this is 3/4 times the fourth root of x, okay? So be comfortable going back and forth between all the different ways you notate these things. They're all equally valid. So don't think it's a matter of being more or less correct. It's more a matter of being equipped to understand the different problems you're going to see, especially on math exams or calc exam, especially AP Calc, in the multiple choice portions. Now, in the free response portions, you don't really have to worry about that because a computer's not grading you. A human's going to grade you. A human who happens to know calculus really well. So you could leave it like this, and a human would look at that based off of the problem and be like, that's correct. Multiple choice, computer, if this is not one of the option choices, then you cannot use that, okay? So get comfortable with the algebra. Once again, most of this is just remembering all that good stuff you learned in pre-algebra like 3-4 years ago, that you can do these kinds of rules with exponents, how to add and subtract fractions fluently, which honestly can sometimes just be the most time-consuming part of these problems. Understanding what you're allowed to do with radicals and exponents and all that good stuff. And all this is really just straightforward if you know the rules and follow them carefully. So that's going to be all for the higher order derivatives. And then I'll record that other one for the other kind of like derivative applications, more conceptually based set of problems.